All right, welcome back. Let's try some examples now that we have some learning about angles underneath our belt from the first page. So number one, it says if two supplementary, that sounds like one of those words from the front. Do you remember me turning the S into an A, adding a little hat to the U and making it 180 degrees? Okay, so two supplementary angles are in the ratio of 7 to 2. And anytime you have a ratio, you probably didn't do a whole lot of work with it in algebra, but the trick in geometry is all you have to do is attach an x to each number. And then we will use those in our equation. Find the number of degrees in the smaller angle. So what's happening is that we have two angles that add up to 180 degrees. So you can think of a straight angle. And we're going to separate that straight angle into two angles. And we're going to call this one 7x, and we're going to call this 2x. So it says two supplementary angles are in the ratio of 7 to 2. We'll find the number of degrees in the smaller angle. So we know that the angle of 7x added to the angle of 2x has to equal 180 degrees because they use the word supplementary. And now all we have to do is go ahead and combine our like terms. 7x plus 2x is 9x. Divide by 9, x comes out to equal 20. Okay, so now they said find the number of degrees in the smaller angle. So now we're going to take our value of x and plug it in. 2 times 20, this angle ends up being 40 degrees, and 7 times 20 is 140 degrees. And you notice that those two numbers add up to 180. They're in the ratio of 7 to 2 if you reduce them kind of like a fraction. All right, but they want to know the smaller angle, and so we'll go ahead and say 40 degrees, and we'll box up our answer, and we'll move to the next problem. Okay. Number 2. It says that the measure of the complementary, remember my little trick of turning the S or the C into a 9, and there's the 0, so 90. So 90 degrees in this one. The measure of the complement of an angle exceeds means to go over with addition. Okay. The measure of the angle by 24 degrees. Find the degree measure of the angle. So because they're saying that they are 90 degrees, we could draw a 90-degree angle. And then we could draw another ray in there to split that angle into two angles. And they're saying that the measure of the complement of an angle exceeds the measure of the angle by 24 degrees. So I'm going to go ahead and call this angle x. And you did this a lot in algebra, like let statements, let the smaller angle be x. And therefore, if you exceed that angle by 24, this would be x plus 24. Okay, and so we can take our two angles now that we have them, add them together and set it equal to 90 degrees, since that's what complement or complementary means. If we go ahead and combine our like terms, and we subtract 24, we end up with a 2x is equal to 66. And we divide by 2, and x comes out to equal 33. And did we answer the question? They said the measure of the complement of an angle exceeds the measure of the angle by 24. The measure of the complement of an angle exceeds the measure of the angle. So this angle is 33 degrees, and this angle is 57 degrees. The measure of the complement of an angle exceeds the measure of the angle by 24 degrees. Find the measure of the angle. So this is the angle they're talking about. This is the complement of the angle, where it is exceeding the measure of the 33-degree angle by 24 degrees. Okay. All right, next one. In the accompany diagram, it says that QR, which is a line, intersects ST, which is also a line, at V. And it tells you that the measure of angle QVS, Q to V to S, is x squared. You know what that means? Plus 8x. Okay. If the measure of angle TVR, so T to V to r. This angle here is 5x plus 40. And if you remember on the front, we had a picture that looked just like this. And if you don't know the relationship between the expressions, think about the relationship between this angle and this angle. And if you remember, these are actually called vertical angles, even though they're not vertical from each other. Okay, turn your paper, then they will be vertical. And we know that vertical angles are congruent. They are the same size, and congruent means equal. So all we're going to do is we're going to take the one angle, and it has to equal the measure of the other angle, because they're vertical, and vertical angles are congruent. Okay, the squared term is going to make us do some more work. It means we're going to have two answers. We will not get them unless we do a process called factoring, and we cannot factor until we're equal to 0. All right, and hopefully you know by now that we want the positive squared term, so he's going to stay put, and we're going to go ahead and subtract the 5x. And we're going to subtract the 40. And what do we have left? We have a square term. 8x minus 5x is a positive 3x. Minus 40 that we brought over equal to 0. We're going to set up our x box since we got a nice easy trinomial. We're going to multiply to negative 40 on the top, and we're going to add to 3 on the bottom. And our numbers are going to have to be, how about 8 and 5? Will that work? If we make 5 negative, it will add to positive 3, and it will multiply to negative 40, and easy trinomials get broken up right into their factors. X squared gets chopped into x and x, one with a plus 8, the other one with a minus 5, and we are equal to 0. T-chart. This factor comes out of its parentheses and gets set equal to 0, and so does this one. On this side, we would subtract 8, and x would come out to equal negative 8. On this side, we would add the 5, and so x comes out to equal positive 5. Now, algebra and geometry are going to butt heads. Algebra says 2 answers. Geometry is probably going to say, no, only one of those answers makes sense. So this one is probably the one that we're going to reject. So let's test him first. It's much easier to test in this expression over here. So we'll do 5 times negative 8 plus 40. And that gives me negative 40 plus 40, which is 0. And in our geometry class, there are no angles that equal 0 degrees, because if they did, you wouldn't have an angle. And so we're going to now have a reason to go back and reject this. Okay, and we will keep x equals 5. Did we answer the question? It says find x, and we did, and so this one's finished. Okay. And going on. How about number 4? It says RS intersects LM. RS is a line and LM is a line. And so we're going to get a picture just like in number 3. So we're going to go ahead and draw our line. We'll call that R and S. And then we have another line that crosses or intersects it. And we'll call that one LM. And they said that they intersect right at P. Okay. And now they tell us that the measure of angle RPL, R to P to L, is 7x minus 11. The measure of angle LPS, L to P to S, is this angle here, is 15x plus 37. The measure of angle MPS, M to P to S, is 5x plus 3. And the measure of angle R to P to M is 19x plus 9. They want us to find the measure of each angle, which means we have to solve for x and then plug it in and then into all those expressions, and then we'll have each angle. All right, so there's a ton of ways we could set it up, and I want to go through them with you. We could set it up just the way we did in number 3. This angle here is vertical with this angle here, and vertical angles are congruent. So that's just one setup. Okay. A second setup that would work. This angle here is also a vertical angle with this one here. And so we could do 15x plus 37 equals 19x plus 9. Okay, we have a couple other options. Does everybody see this straight line here? And does everybody see this little divider on it? These two angles right here make that half circle. Therefore, these two angles would add up to 180 degrees. That's actually a linear pair. This is your line for the linear part. And this angle here and this angle here, there's two of them, and that makes the pair. And so we could also say that 7x minus 11 plus 19x plus 9 equals 180 degrees. Well, we could do that same thing over here as well. If we look at the other side of that line, everybody see this side? See the half circle on this side? So this angle here and this angle here also lie on a line next to each other, and there's two of them, and so they're a linear pair. And so in number 4, fourth way of setting this problem up, we could do 15x plus 37 plus the angle next to it, which is 5x plus 3, equals 180 degrees. And some of you might be saying, hey, wait a minute. What if I go and I do a line? I'm trying to find another color to use. Let's go with this pink color. If I look at this line here, and here's my separator, and there's that half circle, and this angle here and plus this angle here would also add up to equal 180. They would be a linear pair. So a fifth way of doing it is taking that 7x minus 11, adding the angle next to it, which is 15x plus 37, equaling to 180 degrees. Okay, let's look for another way of doing it. Okay, use this gray color. On the other side of that same line, but this way, see that half circle? This angle here plus this angle here would also equal 180 degrees. So we have 19x plus 9 plus the 5x plus 3 equal to 180 degrees. Whew. Believe it or not, there's one more way. All the way around. This is called angles around a point. There's this angle, and if I keep going, this angle, and if I keep going, this angle, and if I keep going around that point, I get this angle, and there's 4 angles there. Angles around a point add up to 360 degrees. So if I take that angle of 15x plus 37, and I add 5x plus 3 to it, and I add 19x plus 9 to it, and I add 7x minus 11 to it. All 4 angles all the way around the point have to add up to equal 360 degrees. Ooh, so if you had to pick, which equation would you solve for x? I'd take that one. That one seems to be the easiest. I would go ahead and solve that one. However, if you do the math correctly, any one of these would come out to be the right answer. If you don't believe me, you can try a few. Okay. But in this one, we're going to get a 2x minus 11 equals 3. Add 11. I get a 2x equal to a 14. And divide by 2, and x comes out to equal 7. Okay. That wasn't the answer to our question. They actually want to know the measure of each angle, and so now we're going to go back and we're going to plug in. And if we do 7 times 7, that's 49, and 49 minus 11 is 38 degrees for this angle here. Wow, good news. We don't have to plug into this expression who's vertical to it. Because this angle would also be 38 degrees. Okay. All right. So we could go ahead and plug into the other ones, or we could say, hey, they add up to 180 next door to it because they're on the same line. They're a linear pair. Okay. Or we could plug in. It doesn't matter to me. Let's go ahead and do plug in. 15 times 7 plus 37 is 142 degrees. Wow. So is he. And if you add all four angles together, you're going to see that it equals 360. If you add these two angles together, you're going to get 180. If you add these two angles together, you'll get 180. If you add those two angles together, you get 180. If you add those two angles together, you get 180. You add all four together, you get 360. So very cool. All right. Great job. And you guys have homework on the next page. So I will see you on the next day of notes.